All right, so now I am still on this equation, or this question. It's kind of a long question. There's a lot of moving parts in it. So we just got done looking for the x-intercepts. Sometimes you're going to have to use the quadratic formula. Other times you can factor, so it just depends on what they're given to you. So now the next question is the y-intercept. So we found the x-intercepts. So the x-intercepts, you set it to 0 and you solve. The y-intercept, you find that when your x value is 0. Okay, so again, if you were looking at a graph, the y-intercept is going to be a point on your y-axis. That's when x is 0. Okay, so that's where that comes from. So again, I have not used any first or second derivative. All I'm doing is looking for the intercepts. So when you're looking for the intercepts, x or y-intercepts, you're using the original function. Okay, so y-intercept is when x is 0. So all I'm going to do is come in here, plug in 0 for my x, and calculate. Well, 0 minus 5 is a negative 5. 0 squared is 0. 10 minus 0 is 0. Minus 50 is negative 50. So these just dump out. That's all it is. Every time you see an x, when it goes to 0, it just dumps out. So that goes away, that goes away, that goes away. All I have is negative 5 times negative 50, which is a positive 250. So your y-intercept is 250. Now, before you probably wrote it this way, in my math lab, you're just going to write what the y-intercept is. It is at 250. Okay? That's the third question. Now it's asking, the function is increasing or it never increases. So now we're getting into first derivative. So now what we need to do is whenever it asks for increase or decrease, you have to find your first derivative. Well, you can use the product rule if you want, but remember, you always want to try to avoid the product rule just because it's a lot more process than you need. So I'm just going to multiply this out. I'm going to use my distributive property and multiply this out and get my set function. So x times x squared is x cubed. X times negative 10x is negative 10x squared. X times negative 50 is negative 50x. Now I'm going to come back to my negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 10 is a positive 50x. Negative 5 times negative 50 is a positive 250. All I've done here is instead of writing out one long polynomial and then having to find what I'm adding together, I just line them up. These are like terms. Makes it much easier to find the answer. So I have x cubed. Negative 10x squared minus 5x is a negative 15x squared. Negative 50x plus 50x, those cancel. So then plus 250. So this is my original function. Now I can go to my first derivative. So my first derivative, again, using the power rule, drop that to the front and multiply, and then subtract 1. And then 2 times negative 15 is negative 30. Subtracting 1, the 250 goes to 0. There's my first derivative. So now we're going to walk through the process of first derivative. So let me erase most of this. Let's see. I'm going to rewrite this one up here. Just x cubed minus 15x squared plus 250. Okay. So my first derivative, I worked through and got 3x squared minus 30x. So I'm going to write that here. Give myself some more room. Okay. So now I'm going to set this to 0, setting first derivative to 0. And remember, when we're working with first derivative, we're looking for the critical points. So I'm going to factor out a 3x. I end up with x minus 10. Again, I can factor or multiply back through and make sure that I get the original one. And now I'm going to solve for 0. So solve for x, excuse me. 3x equals 0, so x equals 0. X minus 10 equals 0, so x equals 10. So these are my critical points. All right, so as soon as I find my critical points, I'm going to set up my test chart for first derivative. Again, label it. It helps because this label tells me what I'm using. I'm using the first derivative function in order to test my intervals. So I have 3 intervals. So I'm looking for numbers that are less than 0. So I'm going to test at -1. I'm going to plug it into here. I like plugging it into my factored form. You can plug it in here if you want. You just have to do calculations. Here, it's already set for me. So 3 times -1 is a -3. -1 minus 10 is a negative. So in this interval, I am increasing. First derivative, I'm looking for increasing or decreasing. Next interval is between 0 and 10, so I'm going to use 1. 3 times 1 is a positive. 1 minus 10 is a negative. So this interval is decreasing. Now I'm going to look in the interval above 10. So I'm just going to go to 20. 3 times 20 is positive. And again, I don't care about the numbers. All I care about is it positive or negative. 20 minus 10 is positive. So I have an increasing interval. So here's my critical points are now showing whether I have maximum or minimum. When it goes up and then down, that's a maximum. When it goes down and then up, that's my minimum. So now I can answer my questions. The function is increasing on the intervals -infinity to 0 and 10 to infinity. So again, with my math lab, you're going to write your answer with a comma. So this test chart is going to answer all your questions when it is based on increasing or decreasing, all right, or max or min when we're working with first derivative. So this is our increasing intervals. Then it says the function is decreasing. So where is it decreasing? It's decreasing between 0 and 10. Okay. Then it says the function f has a local maximum and the function f has a local minimum. So the maximum is at x equals 0. And the minimum is at x equals 10. So again, if it goes up and then down, it's a maximum. If it goes down and then up, that's a minimum. So we're almost done. So now we go to a new set of questions. And the new set of questions, again, based on this same function, we're still working with the same function, is now asking about concavity. So the minute you see the term concavity, now you have to go to second derivative. So I'm going to stop here and then start the second derivative.